Hello, I am Tejal Agrawal. The thesis presented is about the ability to gain employment and the design for an industrial training institute in Dhule, which as named will be turning theory into practice. The site is located in Dhule. The institution is designed focusing on the scale of the city, climatic conditions, and the general socio-cultural diversity. The design is an amalgamation of microclimates created to cool down the space, an hierarchy of courtyards, and a bioswale spine to bind different blocks together. There is a scarcity of employment opportunities in 2 and 3 tier cities, and what little jobs are available, the youth does not match their skills requirements for the local jobs. To train them and share the skills required, a industrial training facility specializing in the local industrial requirements and culture is required. Can get vocational training from the age of 17, that is after completing class 10. But in our educational system, the role of vocational training centers are consistently undermined. The awareness of such programs and the option to switch into vocational training is not presented to the students. In rural areas, formal education does not hold much importance. The minimal education does not provide any skills that can be used for local industries and don't give a chance to grow. The vocational training specified for local businesses is provided these people can get the opportunities to grow in their own towns and local businesses also flourish. Dhule is a large producer of good quality cotton. Many cotton, textile, and cloth manufacturing industries provide jobs in large quantities. The gap between the industrial job requirements and the skills are huge.
Another popular industry in Dhule is extraction of edible oil. Most commonly, groundnuts, soya, and sunflower seeds are used for oil extraction.
To reduce this gap between supply and demand of skilled workers, the government has initiated Skill India program which aims to create opportunities for the youth to improve productivity and give direction through proper skill development for blue collar jobs. Under this program, the government has a scheme commonly known as Sankalp. This scheme is funded by the World Bank for Private-Public Partnership so that the students can learn the working of the industry and new advances in the sectors as well as the working culture in the local factories. Dhule is a major city located in Dhule district in northwestern part of Maharashtra state known as West Khandesh. Situated on the banks of river Panja, Dhule is the regional headquarters of MIDC, RTO and MTDC. Dhule is largely emerging as one of the upcoming hubs of textile, edible oil and power loom across the state and has gained strategic advantage for being on the junction of three national highways. The overall experience of the city is very spacious, a lot of greenery and wide roads. The site is an existing industrial training institute which has been ordered to be demolished as it was built in 1950s. The structure is degraded. The site is along the old Bombay Agra highway. The site is about 1,45,000 square meter. The land is owned by the government. The context is a mix of residential and educational zone primarily. The schools and other college campuses are just across the street, which makes it a student dominated area. Just beside the site, the two water tanks for the area hold about 35 lakh liters of water. The bus stand is recently developed with a space for parking of state travel buses and eateries for the passengers. The contours are at 1 meter intervals, which shows that the site is not sloped. The storm water does not flow off but gets absorbed in the soil. The road leading to the site is the old Bombay Agra highway, which is 21 meters wide, and the secondary road is 9 meters wide. Photos of the public buildings in Dhule show that ground plus one is usually the way buildings are designed in the city. The pictures on the right are from the existing ITI on site. The structure is totally degraded to a point that major cracks can be seen in the beams and columns. Sewage water drainage system lacks maintenance and the toilet water gets clogged in the corridors. There is no shaded spaces for students to hang out or for sports activity. The westerly winds flow through site all year round. The rainfall in Dhule is quite less. It is very hot and dry throughout the year. Dhule experiences more sun time than other cities. As the Industrial Training Institute is government institute, the guidelines given for the designing of ideas is followed. The area requirements and the programs are taken in accordance with the guidelines. The diagram shows the placement of rooms in the volume. Blocks are placed such that hostels are kept in the rear for privacy of the students and the institute is towards the main road. Public amenities are near the entrance of the building. Roads lead to the hostel and the bioswale spine in the center for pedestrian connectivity. These were first designed on site as large rectangular buildings with courtyards. The academic part was further broken into smaller blocks to create shaded space. And in the center was introduced for connectivity from the front towards the hostel. Bridges connected the classrooms to the workshops. The hostels are designed to make the quadrilateral courtyards in between two units that will get shaded from the hostel's shadow. The workshop are further carved for smaller courtyards in between to make spillover working space. Is used in the design for cooling effect and creating microclimate in the courtyards. The bricks are used extensively as it is the local material available. The use of jalis in the openings to ensure ventilation, water bodies, and fountains to keep the courtyards cool and create mist. The diagram shows the placement of the programs. The main academic block is placed along the main road with public amenities near the entrance so that the classes are not disturbed. The workshops are placed together with storage of raw materials in the center to create smaller courtyard which will be used as spillover spaces. In the later phase, the workshops will be placed opposite to make larger shaded spaces for the working. The blocks are placed together so that the pathways are always shaded. The central spine is used as pedestrian path for movement between the blocks. The hostels are placed in the rear end of the site to give privacy to the students to from the hustle of the institute. The 10-meter road cuts into the side for connectivity to the hostel. The design is for the first block here, and the second and third block are considered to be built later, following the design guidelines such as architectural style and height of the building. Here, the same plan are used for the other phases to understand the volume and density of the site. As we enter into the site, the roads leads us to the hangout space below the amphitheater, as we see here. Right is the entrance to the building. The entrance is a double-heighted space with jali wall on the south. Towards the auditorium, we climb a few steps to enter. It has two green rooms for the artists. It has a sitting capacity of 240 people. The space below the auditorium is shaded from the harsh sunlight by jalis, creating a semi-shaded space for hangout. The exhibition space is placed closer to the workshop with entries on two sides for better circulation. On the other side, the accounts office, job counseling rooms, offices for a principal, vice principal, and department heads are placed with a waiting lounge. The medical room, in case of emergency, has 3 bed capacity. The library has a lounge sitting for groups. The bookshelves are placed along the wall. The faculty lounge has a pantry and set of 4 desks together. The faculty room leads into the meeting or conference room. After walking up a few steps, it's the canteen, kitchen, and the sitting area along the small water body for the cooling effect. In the end, students' recreation or sports room is placed. The courtyard has semicircular amphitheater surrounded by vegetation. The central big water body acts like a mist system for the courtyard to beat the climatic dryness. The trees, bushes, planters create a small ecosystem in the courtyard. The plaza is the in the courtyard becomes a casual spot for students to spend time between classes. The workshop has 2 entrances, one from the courtyard and the other from the smaller courtyards. The double-heighted workshop is clear space with no hindrances so that the groups can work easily. Common storage space between the two workshops, the smaller courtyard formed between these workshops work as spillover space. Is the bioswale with pedestrian paths on both sides. The bioswale collects the storm water and replenishes the groundwater table. The staircase blocks and lift take us to the first floor. First floor, all the classrooms, seminar halls, computer labs, and audio video rooms are placed. The landscape feature on the first floor is for the people to wait around for their classes. The planters on the floor are placed to keep the place lively. The bridges connect the academics to the practical workshop classes. The classes have been partitioned to look into the workshops below. The roofs are semi-slope for creating shadowed spaces. The gutters are placed at the slopes to channelize rainwater. More than 900 solar panels are placed on top to utilize the abundance of sunlight available. The space frame pergola is designed to get support from the bridges and the buildings on all sides. The pergola is made of steel sections and translucent colored sheets to protect from the direct light. This section is from the workshop and smaller courtyard. The volume of the workshop is big so that the hot air rising from the machines will rise and get out of the jali. The span of these workshops is 20 meters, so double-ribbed waffle slab system is used. The working classroom is placed above the storage. Courtyard is covered by lifted sunroof to keep the area well lit and for the hot air to escape from the space in between. Here we see the relation between the workshop and the central courtyard and spine. The other unit of the workshop works in the same way. The staircase is folded slab system with planter at the bottom. This is a section from the workshop showing the relationship between the class above storage and the working space. The storage space has an entry from the workshop directly. There are fins placed together in the classroom so that one can observe workshop from there. Connects the blocks as pedestrian pathway. The pathway is lined with trees on both sides with benches. The difference in the volume of workshops and how the storage and classroom are sandwiched in between is seen. Through the exhibition space, plaza, and the recreational or sports room, the exhibition space is double heighted. The water from the sloped roof is drained from the gutter into the soaking pit to replenish the groundwater levels. The bridge that connects the academic part to the workshop is rested on the smaller columns. A ribbon window is designed so that people can see into the courtyard. Gradual step up of the plaza surrounded by trees, bushes, and water body makes it a cool and controlled space for casual hangout between lectures. The students' recreational room is stepped up from beside the smaller water fountains. Section through the academic block showing the placement of classes, offices, and auditorium. On the ground floor, we see the faculty room and the offices on the right. On the upper floor, there's the AV room and computer lab. And the classrooms are placed along the main road in the bar-like building. The steps of the auditorium is made in folded plate technique. The seats are placed in slight arc for proper viewing points. The space below the auditorium is used as a hangout space which is shaded by the auditorium and the jali for protection from harsh sunlight. Section through the academic block and the central courtyard showing the density of greenery and water bodies below the space frame. We see the corridors, offices and classrooms above in the section. And in the elevation, the bridge connecting the two blocks with the ferns hanging from the sides, the connection to the workshop and the benches along the spine. Section through the bridge showing the connections to the academic and the workshop blocks. In section, we see the head of department's office and the open space above. The bridge is one-way ribbed slab system with ribbon window running along the whole length. It connected the balcony to the classrooms above the workshop. The overhang of the classroom keeps the below corridor protected. The courtyard is covered by lifted sunroof for filtered light to enter the courtyard and for the warm air to escape from between the space. The plantation of small trees, hedges make the courtyard comfortable. Building elevation from the main street, the hangout space below the auditorium is seen along with the shops and solar panel room. The bar-like building in which offices and classrooms are placed, the space frame floating above ties all the blocks together. The building is lined with various bushes. The difference in the depth of blocks can be observed. The hostel block is placed at the rear end of the site. The hostel is ground plus two structure in a stepped design. The ground floor has two bedded rooms. The first floor is offsetted by 2 meters and have four bedded dorms. The top floor has three bedded rooms with an offset of 4 meters. The ground floor has the filing and the warden's office. One unit has 145 beds. Aerial view of the site. Exterior view of the site showing the Industrial Training Institute. From the entrance of the institute towards the entry of the building, one can see hangout space below the auditorium. From inside of the hangout space. View of the amphitheater with the vegetation around it. Plaza in the main courtyard with the view of workshop and the bridge. Plaza with the view of workshop, planters, trees, main water body and the space frame that creates shadowed patterns. View from the plaza towards the academic block and the courtyard. View of canteen from the recreational room. The smaller water body and the bridge are seen. The filtered light and shadow patterns are created all around the courtyard. From the courtyard looking towards the plaza, main water body and the vegetation in the courtyard. Spine connecting the blocks together, the plants and the bioswale with the pedestrian path on both sides with benches and the trees for shade. View from the pedestrian path towards the academic block and the courtyard, the main water body, plaza, the vegetation with the shadow patterns from the roof above. View from the first floor corridor towards the main courtyard, the structural support of the space frame roof is seen. View from the first floor corridor towards the main courtyard plaza, bioswale, spine, bridge, and three water bodies are seen. The landscape seating on the first floor with the bridge and space frame roof. View from the plaza in the courtyard towards the academic block, we can see the staircase block. View of smaller courtyard and workshop, the smaller space frame roof to cover the spill out spaces, the fins on the end of the workshop for ventilation. Wall section through office and classrooms to show the double window system, interior sliding window and the outer vertical ribbon windows. Section to show the connection between classroom and the bridge. The overhang of the classroom shades the corridor below. The bridge is supported by smaller columns. Section for the jali at the entrance of the building. The triangularly placed bricks create patterns in the jali. Wall section through the plinth of workshop to understand the connection of the space frame on the columns, the sloped roof and the gutter connection for rainwater drainage, detail of space frame structure with steel sections and tinted glass panels. Shadow analysis of the site in the morning. The sun from the east creates long shadows which keep the courtyards shaded. By 11 the sun is almost overhead, hence short shadows are formed. In afternoon the sun is in the west direction, hence the shadow are forming on the east. In evening long shadows fall on the east side, shading all the courtyards and middle spaces. It helps because in the evening students are free to spend time in the open spaces. The sun plot diagram shows the sun is overhead in the summer season, so shadows are short, and in winter the sun is at a shorter angle, hence longer shadows fall from the structure. The wind flows through west, so to break the flow of these dry and hot wind, the workshops are placed with jalis and fins. The windows and jalis are placed in east-west direction to naturally ventilate the space. Site gets municipal water twice a week, so water requirements are met by bore wells. The water tanks are divided in three parts: domestic flushing and firefighting. The water in domestic tank is from the municipal line and bore wells. The flushing water and the firefighting tanks are for the recycled water from the sewage treatment plants. Rainwater from the roof are channelized by gutters into the soaking pits to improve the groundwater table. The annual rainfall in Dhule is less, so the rainwater harvesting tanks are expensive to maintain. The sewage from the toilet is treated in the sewage treatment plant. Series of inspection chambers lead the waste to the STP. The recycled water will be used for flushing, gardening, and the maintenance of site. Dhule receives 11 hours of average sunlight throughout the day. To utilize this, solar panels are placed all along the terrace, so the electricity requirements are met. The value of solar panel installations can be recovered within a few years. Base frame roof is made of sections and tinted fabrications are on the top and bottom to reduce the hardness of the sunlight and create shadowed patterns. The circulation on site is such that the central spine is the pedestrian path and the road along the southern edge is the vehicular access into the site towards the hostel. The car parking is provided near the entrance of the site. The two-wheeler parking spots are available near workshops in each block. Water availability in Dhule is less, hence the plants and trees that use less amount of water are used. Most vegetation are low maintenance and grow on their own. The smaller bushes, hedges and ferns need to be taken care of. The exploded axonometric view of the structure, the space frame roof and the parapet walls. This shows how the sunroof sets on the parapet. The sloping roof shows the double rib slab system and the first floor walls with extracted doors and windows to see how it all sets together. The lower level slab with cutouts for the double heighted spaces, the ground floor walls with extracted doors and windows to show the assembly of all the components. Plinth with the staircase and lift blocks, amphitheater and water bodies in the courtyard, the column and lift shaft to show the location of columns. Thank you.